Okay, so in this video we're going to look at the strengths of acids and bases. So let's talk about hydrochloric acid first. Is it an electrolyte? You've seen me light the light bulb with it, so you know that it is. We know that it's a strong electrolyte because it lights it up fairly brightly. And so why is it an electrolyte? We know it's an electrolyte because it forms ions in solutions, even though it appears to be a covalent compound because of its formula. So let's think about acetic acid. Is that an electrolyte? When I put it on the light bulb, it will light the light bulb, but not nearly as much as the hydrochloric acid. And so it is an electrolyte because it makes ions in solution. All acids do that. But it doesn't light up as much as the hydrochloric acid. And that's kind of like what we saw when we did the aspirin in the types of bonding lab, that it was a very weak electrolyte. They both produce hydronium ions. That's what makes them acids. But the difference comes from the strengths of the acids. So let's look at why those are different. Hydrochloric acid completely dissociates. So when you put hydrochloric acid in water, it completely breaks into hydronium ions and chloride ions. So basically there are no molecules of HCl left. Molecules of HCl won't conduct electricity in water. Remember that in order to conduct electricity, you have to have charged particles like ions that can move around. And molecules are not charged, they're neutral. When you put acetic acid in water, it doesn't make as many ions. Acetic acid only partially dissociates, and it is an equilibrium expression. You can see with the top reaction with the hydrochloric acid, there's a one-way arrow. It basically all goes to the ions. With the acetic acid reaction with water, you can see that it's an equilibrium system, and only about 0.5% of those acetic acid molecules make hydronium ions. And so that means only about 1 out of 200 acetic acid molecules will split into its ions. And the ions are the only particles in that equation that will carry a charge. So most of those molecules stay in the molecule form. They don't split apart and form ions, so they don't conduct as much electricity. And we say, when we look at that reaction, since most of the acetic acid molecules don't split, we say that the reactant side of that reaction is very favored. So when we talk about a strong acid or base, we're talking about an acid or base that completely reacts with water to form either hydronium or hydroxide ions. And when you think about it, you'll probably recognize these. The strong acids are hydrochloric acid, sulfuric acid, and nitric acid. There are others, but these are the only ones that you need to know for this class. You will need to memorize these. You'll need to know the difference between the strong acids and the weak acids. Okay, and the strong bases are lithium, sodium, potassium, rubidium, cesium, calcium, strontium, and barium hydroxide. And I know that you're looking at that thinking there is no way to memorize all of those. But look at your periodic table and see if you can see a pattern. And we will talk about that in class tomorrow when we discuss the video. There's a pretty simple way to remember those actually. The good news is the weak bases are a little bit easier to remember. Weak acids or bases are acids or bases that only react partially with water to form hydronium ions or hydroxide ions. So they don't completely come apart. There's still lots of acid or base molecules left in the solution that won't conduct electricity. And weak acids are all the acids other than strong acids for us. And then weak bases are every one but the strong bases. So when you think about it, like aspirin, which is acetyl salicylic acid, that's a weak acid. And sodium hypochlorite, that's something that's in bleach. That's also a weak base. Here's another way to look at it. If you have a strong acid, before you put it in water and it dissociates, everything is the acid molecule. So H, remember that ionizable hydrogens at the front of the formula show you that it's an acid. So HA is just like a generic acid formula. After it dissociates it at equilibrium, basically it's all hydrogen ions and acid ions, whatever the, like chloride ions for hydrochloric acid, whatever that other part of the acid is. With a weak acid, it starts off with the acid molecules, and then in water, some of those molecules, usually just a few, will dissociate and form those hydrogen ions and the acid ions. But only a little bit, enough to give it some conductivity, but not enough to make it a strong conductor of electricity in water. All right, so let's look at what that does. Strength is not the same thing as concentration. So let me give you an example. If you think about what we call glacial acetic acid, that has a concentration of 99%. So it is very, very strong. And I have some of that in the stockroom. We also buy sulfuric acid in a concentrated form. That's 98%. Both of them have about the same concentration, 99 and 98%. But acetic acid won't ionize nearly as much in water as sulfuric acid will, and that's because acetic acid is a weak acid. But if you notice, its concentration is actually greater. They just behave differently because acetic acid does not dissociate completely in water. Don't confuse these. Strength is completely independent of concentration. All right, here's a cartoon for you. All right, well, I hope you enjoy that, and we will talk about this in class.